Hi, this lecture is the continuation of our last lecture. In the last lecture, we studied about what is the internet and then what is a protocol. Today, we'll proceed with the network edge. We'll study about hosts, access networks, and physical media. So let's get started. Okay, so since we are having a nuts and bolts view of the internet, that is the software and hardware components which makes up an internet. So as I've already told you that these devices, these end devices or end systems, we call them the end systems because they're present at the network edge. So what does this term network edge means? What do we mean by the network edge? So the network edge or at the edge of the network, we have these end devices. Like for example, the smartphone over here, this laptop over here, the smart car, the car over here, the smart fridge over here. So at the edge of the network, we have the devices, or you can say the network edge constitutes of these end devices as well as the applications. For example, the Google Chrome application, your WhatsApp application, the applications which you use to send data over the network. So a network edge constitutes of these end devices as well as your applications. So um, hosts are sometimes further divided into clients and servers. I've already told you in the last lecture that we will be using these two terminologies, hosts and end systems or end devices, interchangeably. So host and end systems or end devices mean the same thing. So hosts are further divided into clients and servers. Clients are actually computing devices, and servers are actually a very high power, a very high computing devices, and generally they are present in the data centers. For example, Google have 30 to 40 data centers, and each data center contains thousands of servers. So the servers are always in the listening states. They are always on. They are always listening to the requests made by the clients. So we will study about the servers and clients later in this course. Okay, so now what are access networks and what is a physical media? So have you ever imagined how are these end devices? How is this laptop connected to this internet over here, or how is this laptop connected to these the other networks present inside this larger network? So how is this mobile phone connected to this internet? So access networks are the networks that physically, access network is a network that physically connects an end system to the first router. So this is an example of an access network. An access network is a network that physically connects an end device. For example, in this case, we have this laptop over here or this mobile phone over here. So the network which connects these end devices physically to the first router, or we call them the edge router. So this router over here, this is known as the edge router. So the network which connects these end devices to the first router, which is the edge router, that network is known as the edge network. So let's say this router over here, this router is known as the edge router, and here we have this router. This router is called as the edge router. So through these edge routers, we have connected these devices to the internet. So let's suppose, just wait a second. So this mobile network is connected to this network over here using this router. So this router is known as the edge router. We have connected this network to this network over here. Sorry. Let me remove this. Okay. Okay. So we have connected this mobile network, you can see over here, to this network, or you can say these two networks are connected together using these routers. So this router is present at the edge of uh, the respective network. So this one right there is present at the edge of this network. So these two networks are connected together using these to edge routers. So an access network is it's a terminology used in, or it's a jargon used in computer networking. So access networks are networks that physically connect an end system to the first router, which is the edge router. So which in turn connects this to the other networks in the system. Okay, then we have the physical media. Physical media is physical media includes the wires, the coaxial cable, the fiber optics, which physically connects the end systems or different routers together. So we have the wired physical media, and we have the wireless communication links as well, such as Bluetooth, such as Wi-Fi, etc. Okay, so we are moving from the network edge. So we were present at the network edge. We were studying the network edge. So this was the network edge, and now we are moving inwards inside the network. So inside the network, we have the network core. So what do we mean by this term network core? So a network core is the mesh of packet switches. You can see these are the packet switches. We have the routers, the packet switches. So the network core is the mesh of packet switches, or you can say the mesh of routers and links. These are the links. You can see these are the links. So these routers are physically connected together using the physical media. This over here. So these routers or these end devices are connected together physically using the physical media. That physical media can be wired. Let's say we have these routers are connected together using coaxial cables, for etc., or copper wires, or these links can be wireless. For example, WLAN. Okay, so we were studying about the network core. We are present at the network core. We were studying about the network edge, and now we are here at the network core. So network core is the mesh of packet switches or routers and links that interconnects the internet's end system. So inside the network, we have the network core, and we have the interconnected routers. And then, as we've said, network is a network of networks. Internet is a network of networks. So here we have one network, here we have another network. So these two networks are connected together using the edge routers or access networks. So here we have this one as well. This is another network as well. So we have different networks. So all of these networks are connected together using access networks. So inside the network, we have the network core. Okay. Okay, so how to connect end systems to edge router? How are these end systems connected to the edge router? From now onwards, we are now going to study how you can imagine how is your home connected to the internet. You may have a DSL modem at your home. You may have a wireless access point at your home, which may be present in a router that you're using at your home. So now, from now onwards, we are going to study how is your home, how is the router at your home, how is the DSL modem at your home, how is that connected to the internet. So how to connect end systems to edge router? We have the residential access nets. We have the residential access nets. Residential access nets includes the DSL and the cable systems, the cable internet systems. Almost 90% of the houses in the United States, they use the DSL and cable internet systems to connect to the edge routers. Okay, then we have institutional access networks, which may be present at schools and the companies and universities. And then we have mobile access networks, which includes Wi-Fi, 3G, 4G, 5G, and LTE technologies. Okay, so we're now further talking about the access networks. We'll talk about these residential access networks. So as I've already told you, we'll now study how are your homes connected to the internet. How is the DSL modem, which is present at your home, connected to the internet or connected to the edge router of the network? So we are studying about this residential access network. So this residential access networks, we have first we have a cable-based access. So in a cable-based access, the same company which provides the TV services, you can see over here we have a TV. So the same company which provides a television infrastructure provides the internet facility as well. So that is known as the cable-based access network. So this cable head end is present at the office of your cable provider company. This cable head end is, this is present at the cable provider company, and let's suppose this is your home. So we have the same wire, we have the same cable. You can see here we have a larger picture of this cable. So the same cable, same wire is used to provide TV facility and the data facility, or that you can say the internet facility as well. So we have the same wire, same cable is used to provide both the internet facility, that is the data facility, as well as it carries the TV signals as well. So this is known as the cable-based access. At your home, you have a cable modem. You can see this cable modem. It's, keep in mind, it's not a DSL modem. It's a cable modem. Since we are studying the cable-based access network, so we have a cable modem at a home, and then before that, we with that cable modem, we have a splitter. Here you can see the splitter. Let me remove this ink. Just a second. Okay, so you can see the splitter over here, and you have a cable modem over here. We are connected to the internet using this cable modem. And what is the purpose of this splitter? This splitter actually splits the data from the analog signals. The analog signals, since we have single cable, this is a coaxial cable. You can see this is a coaxial cable. So the single coaxial cable is used by your cable company to provide you both the data and the TV facility. So the splitter over here, it splits the data and it sends the data to this cable modem so that you can connect to the internet, and then it splits the TV signals, or you can say that the analog signals, and sends to the TV. So it is the job of the splitter to split these two separate signals, the data and the analog signals. Okay, so back in the office, back in the cable company's office, we have a cable head end. So the cable head end, we have another residential office in between these two entities. So the cable head end is connected to that residential point using fiber optics, and then that residential point, it provides internet to your homes. So these houses are connected together using coaxial cables. Let me draw this for you. So these houses are connected together. You can see these houses are connected together using the coaxial cable. So this is the coaxial cable, you can see. This is the coaxial cable. So this is the larger picture of the coaxial cable. So these houses are connected using the coaxial cable, whereas this cable head end, is connected to that point using fiber optics. So we are using both the fiber optics as well as the coaxial cable. So this is why we call it, just a second. This is why we call it hybrid fiber coax. Hybrid fiber coax. Why do we call it hybrid fiber coax? Because we are using both the fiber optics and the coaxial cables in this cable-based access system. Okay, so since we have already discussed that we use the same cable is used to transmit both the data and the analog signals. So how are these signals separated from each other? The answer is frequency division multiplexing. FDM. We have different frequencies set for different signals. We have different frequency for the transmission of data, whereas we have different frequency for the transmission of analog signals. So frequency division multiplexing, it means different channels transmitted in different frequency bands. So different frequency band for the data and different frequency band for the analog signals. So this is how we transmit both the data signals and the analog signals through one single cable wire, which in this case is a coaxial wire. Okay, so I've already told you what is a hybrid fiber coax. This cable-based access network, or this hybrid fiber coax, is asymmetric. What do we mean by asymmetric? Asymmetric means there's a slight difference between the upstream and downstream. So the downstream is slightly higher than the upstream, which is the case with the DSL system as well. So it is asymmetric. Asymmetric means there's a slight difference between the upstream and downstream, and it is up to 40 MB per second to 1.2 GB per second downstream. So this is the downstream capacity or downstream transmission rate, and 30 to 100 MB per second upstream transmission rate. You can see that the downstream over here, the downstream in this case, this downstream is slightly higher than this upstream. In the case, I repeat, in the case of hybrid fiber coax or the cable-based access networks, we have upstream, we have the downstream, which is slightly higher than the upstream. So when we have the downstream, which is slightly higher than the upstream, then we call it asymmetric. Asymmetric. Okay. Now, what do we mean by downstream and upstream? Just for the simplicity, you can think of downstream as download speed. For your simplicity, you can think of the downstream as the download speed and upstream as the upload speed. Okay, there are different channels for the transmission of data. For example, you're downloading something, you're downloading a video, you're downloading a movie, you're downloading a music, you're downloading a song from over the internet. So that means you are gaining, like it means you are using the downstream channels. You're using the downstream channels to download stuff from the internet. So whenever you have to download something from the internet, whenever you have to download music, movie, songs, etc. from, or picture from the internet, you use the downstream channels. So this is why we call it, we can think of it as a download speed. Okay, whenever we have to upload something to the internet, whenever we have to upload, let's suppose you want to upload a movie, or let's suppose you want to upload your pictures to the Google Drive. So you are uploading your data to the internet. So whenever we have to upload the data to the internet, we use the upstream channels. Okay. So whenever we have to download something from the internet, whenever we have to download something, so whenever we have to download something, we use the downstream channels. I'm denoting it with DS, downstream. And whenever we have to upload something, or whenever we are uploading something to the internet, we are using, let's suppose, upload. Whenever we are uploading something over the internet, then we are using, the upstream channels. Upstream channel. So to sum up my discussion of downstream and upstream, whenever we have to download something, whenever we have to download stuff from over the internet, we use the downstream channel. Whereas whenever we have to upload something on the internet, we use the upstream channel. You can think of the downstream as the download speed, or upstream as the upload speeds. So in the case of cable-based access networks, we have the downstream transmission rates slightly higher than the upstream transmission rate. Okay. So moving forward, network of cable fiber attaches home to ISP routers. So as I've already told you, from this cable head end to that residential access point, we have the fiber optics. Fiber optics is used to connect this cable head end. That access point is not drawn over here in this website, in this picture, but it's present. It's drawn in the picture, which is present, which is given in your book. So I would suggest you to read the book to better understand this concept. So this cable head end is connected to that access point using fiber optics, and that access point further connects the homes using the coaxial cable. So that this is why we call it hybrid fiber coax. So it's a network of cable fiber attaches homes to ISP router. Homes share access network to cable head end. Okay, then we have another type of access network. Keep in mind, we are studying the residential access network, the digital subscriber line DSL, the most commonly used access network uh, to connect to the edge router. Okay, so DSL. Let's study about the DSL. It use existing telephone line to central office DSLAM. Okay, so you can see this line over here. This line is actually representing the cable. So keep in mind the DSL service, the digital subscriber line, this DSL service is provided by the same telephone company, which is providing you the telephone or landline services. You can see this telephone over here. So the DSL service, the digital subscriber line service, is provided by the same telephone company which is providing you with the landline facility. So the existing telephone lines are used to transfer both the data as well as the analog signals in this case as well. For example, we have both the data and the analog signals, data for this DSL modem and the internet, and analog signals for this landline services. So the same telephone line is used to transmit both the data as well as analog signals to transmit for the transmission. So here we have DSLAM, which is present at the CO central office of your telephone company. Okay, so DSL obtains from the same local telephone company that provide its wired local phone access. So DSL services are provided by the same telephone company. Okay, so now let's try to understand this diagram over here in order to understand this DSL better. So we have this central office. This central office is located at your the telephone company. So they have this DSLAM. DSLAM stands for Digital Subscriber Line Access Multiplexer. So what is the job of this DSLAM? Let's try to understand this. As we have already discussed that this same cable, the telephone cable, is used to transmit both the data and the telephone signals. So at our homes, we have the splitter. The splitter splits the data and sends it to the DSL modem. Data is split and sent to the DSL modem, whereas the analog signals are sent to the phone. So it is the job of the splitter at a home to split the data from the analog signal, and it sends the data to this DSL modem, and then it sends the analog signals to the telephone. Same job is done at the central office by this DSLAM. DSLAM, it actually it splits the data and sends it to the network. So data is sent to the network. So DSLAM has splitted the data. So data is split and sent to ISP, and the analog signals are sent to the telephone network. So the same job of splitting, which is done at our homes using the splitter, is done at the central office using this DSLAM. Okay, so why is data transmitted at different frequencies over dedicated line to central office? Of course, we have one single cable to transmit both the data and the analog signal. So we have different frequencies. So we have encoded it with different frequencies to transmit both the data. Data is encoded at different frequency, whereas the analog signals, they are encoded at the different frequency. So we have encoded both with the different frequencies to in order to send both the signals simultaneously. Okay, so we have studied about this DSL. Again, we use existing telephone line to central office DSLAM. Data over DSL phone line goes to the internet. So voice over DSL phone line goes to the telephone network. I've already told you that this DSLAM, it splits the data and sends it to the internet. This is the internet, ISP, internet service provider. This DSLAM splits data and sends it to the internet and sends the analog signals to this telephone network. So this is how the same cable, the same telephone line is used to transmit both the data facilities as well as the telephone facilities. Okay, again, these are the standards: 24 to 52 MB per second dedicated downstream transmission rate. In the case of DSL, we have 24 to 52 MB per second downstream transmission rate, whereas in the case of cable-based access, we have 40 MB per second to 1.2 GB per second downstream. So you can say that the downstream here in this case of DSL, it's slightly lower than that in cable-based access. So we have 24 to 52 MB per second dedicated downstream transmission rate and 3.5 to 16 MB per second dedicated upstream transmission rate. Again, the downstream is slightly higher than the upstream. Again, downstream is the channel which is used when we download something from the internet, and upstream is the channel which is used when we upload something to the internet. You can think of downstream as download speed. You may have checked your internet speed using speedtest.net. You may have come across these two terminologies, download speed and upload speed. So you can think of this downstream as the download speed and upstream as the upload stream. Okay, so you may have a DSL modem at your home, which may look like this. You may have a DSL modem, which may look like this. So this modem, this single box, it contains router. Keep in mind, the router is present. The routers which we are talking about until now, these routers, one of that router is present inside this DSL modem, which is present at your home. So it has the router as well as the access point. So all of these things, all of these three things, they are present inside one single box. In this case, your DSL. So this is to from head end or central office. So this thing is present inside this DSL modem, and this is the router. This one over here, it is the router, and then we have the wired Ethernet 1 GB per second, and then this is the Wi-Fi wireless access point. So we have the router as well as the Wi-Fi wireless access point. You may be connected to your DSL or your router using Wi-Fi. Your smartphone may be connected using the Wi-Fi. So that Wi-Fi is actually provided to you by the Wi-Fi wireless access point, which is present inside your DSL modem. So we have all these three things, the wireless access point, the router, and this to and fro to and from head end or central office. This device over here, we have these three devices present in this single box, which is the DSL modem. So often combined in a single box. Okay, so wireless and wired devices. This computer over here, it may be connected through the Ethernet. You can see these Ethernet ports over here. These are the Ethernet ports. So you can connect the devices, your computer or laptop, using Ethernet cable, using wired Ethernet cables, or you can connect your laptop, your smart fridge, your smartphones, using the wireless access points. Okay, then we have wireless access networks. Up until now, we have talked about the cable-based access networks, which included the DSL and um, the cable-based access network. So now we're moving towards the wireless access network. So shared wireless access network connects end system to router via base station, also known as access point. So we have the wireless local area networks, WLANs. They are typically used within or around a building. They have shorter range. They cover up to 100 feet. So these are some standards of Wi-Fi, and these are some transmission rates. So this WLAN is actually present inside your DSL modem. Okay, then we have the wide area cellular access networks. You may have seen the tower of a telecommunication company, which is providing you with the telephone signals, sorry, with the cellular signals, with your yeah, cellular signals. Okay, so these are used to connect to the internet. These the same company, the same cellular company is providing you with the 4G, 5G, and LTE services. So if you're in Pakistan, you may have the companies Jazz, Mobilink, Ufone. So all of these are the cellular companies. So they are providing you with the internet services as well. They are providing you with the 4G, 5G, and 3G LTE services as well. So this is known as wide area cellular access network provided by mobile operators. So this is the wide area cellular access network is provided by your mobile operator. So the range of wide area cellular access network is actually it's normally 10 kilometers, and this is the speed. They provide you with a 10 MB per second speed. So okay. Moving forward, we have enterprise networks. This is normally used in the schools, big companies, and universities. So it's a mix of wired, wireless. Let's suppose in your lab you have a wired network. You can think of this as in your lab you may have a wired, whereas you may also have the wireless link technology. Sorry, the recording got disrupted. So, okay, so um, in the enterprise networks, we have a mixture of wired as well as wireless networks. Here you can see here we have Ethernet switches, and with the Ethernet switches have Ethernet ports inside them. So the computers, for example, the computers which are present in your labs at your schools or at your universities, those computers are connected to the Ethernet switches which may be present inside your labs. You may have seen these switches inside your computer labs. So these computers are connected to these switches using Ethernet wires. These switches have Ethernet ports inside them. So here you can see we have the wired Ethernet network. Simultaneously, the laptops they can be connected to the wireless access points. So this is the enterprise networks which may be present in the companies, in the universities. They're a mix of wired wireless link technologies connecting a mix of switches and routers. So we have multiple switches, we have multiple routers inside an enterprise network. So it's a mixture of wired as well as wireless technologies, and we have multiple switches and routers. Okay, so Ethernet is actually a very fast wired access. It provides 100 MB per second speed and 1 GB and 10 GB per second as well. And the Wi-Fi, the wireless access points, they provide the speeds at 11 MB per second, 54 MB per second, and 450 MB per second. Okay, so at last we have the data center networks. Uh, in the data center we have hundreds and thousands of during the start of this lecture is in the start of this lecture I have told you that the servers are normally present inside large data centers, as we have discussed that Google have 30 to 40 data centers, and each data center has thousands of servers inside it. So a data center is actually a center in which we have hundreds and thousands of servers together, and they provide high bandwidth link from 10s to 100 GB per seconds. Okay, so now let's understand how the host it sends the packets of data. So host sending now let's discuss the host sending function. So the host takes the application message. For example, you are using Google Chrome, you're using Microsoft, you may be using Microsoft Edge for browsing the internet, or you have sent an email over the internet. So that email application, that may be Outlook, Gmail, etc. So that is considered an application. So the host sorry the host it takes application message, and then it breaks that message, that data, into smaller chunks known as packets. In the jargon of computer networking, we call the data which is converted into smaller chunks by the host, we call it as packets. So the host it converts, it first takes the application message, and then it breaks it into smaller chunks known as packets of length L bits. So L is the length of the packets. L is the length of the packets which the host has broken into after receiving the message from the application. So the host then transmits packets into access network at transmission rate R. So this is the access network. This may be a cable, this may be a link. So the host sends these packets to this link at the transmission rate of R. So R is the link transmission rate. It's also known as capacity, or also known as the link bandwidth. For example, we have a copper wire over here, or we have a fiber optical wire over here. So we can have a coaxial wire over here. So we will definitely have different capacities for different uh, types of the media, the physical media used over here. We will have different capacity for fiber optics, or we'll definitely have different capacity for the coaxial wire. Okay, so in order to find out the packet transmission delay, we divide the L, which is the time needed, sorry, the length of the packets, with the R, which is the link transmission rate in this case. So the time needed to transmit L bit of packet into the link is L over R. Okay, so now let's discuss about the physical media. Physical media is the media which connects different routers and different devices together. It may be, we have already discussed, it may be wired physical media as coaxial cables, twisted pair cables, fiber optics, and it can be wireless physical media. So a bit propagates between transmitter and receiver pairs. Let's suppose this is the host. This host sends the data. So this data would be transmitted in the forms of bit to the other end device in the network. So those bits would be transmitted, or it would propagate between the transmitter receiver pair. Let me explain this. Okay, suppose you have this host A. Suppose we have this host A, or this can be the host, this can be the end device, and here we have a network of different routers in between. So these routers are connected together. In actual, the internet or the network core is not that simple. I'm just drawing this simple for your simplicity. Okay, here we have the host B. So this host A, it sends data to this host B over here. Okay, so here we have routers. These are the routers connected together. You can think of it as network core. So this is host A. It wants to send data to the host B over here. So the host A, it will send the data in forms of bit. Let's suppose we have a bit over, let's suppose this router over here, um, just a second. Okay, so this router receives a bit from host A. I repeat, host A send the data in the form of bit. For simplicity, let's suppose we have one bit. A has sent one bit. So this router over here, it received that one bit. This router has received one bit from the host A. Now, this router will send or will transmit the received bit to this router over here. This router will send the received bit to this router in the network now. So this router over here, it will now act as a receiver. This is a receiver. RECEI. Sorry for the writing. So this is this router over here. It's now the receiver, and this one is now the transmitter. Before that, previously, this was the transmitter, the host A was transmitter, and this router was the receiver. And now, let's suppose we have the bit at this router. Just a second. Okay, we have the bit present at this router. Now, this router will send the bit to this router over here, let's suppose. Okay, now it sends the bit to this router. So this router is now acting as a transmitter, and this router over here, it is acting as a receiver. So this thing, this combination continues until this bit reaches this host B. Please note that we may have different links. For example, the link between these two devices, these two routers, was of coaxial cable. Let's suppose we have a coaxial cable in between these two devices. So the physical media between these two were different. And the physical media between these two routers, let's suppose these two routers, it may be a fiber optical wire. So the physical media between the devices, between the transmitter and receiver pairs is going to be different. So the bit propagates between transmitter and receiver pairs. Physical link, what lies between transmitter and receiver? These are the physical links. These are the physical links. So the physical link can be different. So we have two types of physical media. We have the guided media, and then we have the unguided media. In the unguided media, the signals propagate in solid form. For example, we have the copper wire, we have the fiber optical wire, we have the coaxial cable, we have the twisted pair cable. So these are known as the guided media. In the unguided media, the signals propagate in air. The signal propagates freely. For example, the radio, Bluetooth, Wi-Fi. So these are the types of physical media. Let me clear my board. Just give me a second. Okay, so now let's discuss about different physical media, the guided physical media. We have twisted pair cable. In the twisted pair cable, we have two insulated copper wires. We actually have pairs of insulated copper wires. You can see here we have three pairs of insulated copper wires, and then we have different categories for the twisted pair cable. We have category 5, it provides 100 MB per second bandwidth and also 1 GB per second Ethernet. Also, the category 6, it provides 10 GB per second Ethernet bandwidth. And then we have a coaxial cable. We studied in about the coaxial cable when we were studying about the cable-based access network. In the cable-based access network, most of the time, generally the coaxial cables are used. So the coaxial cable, you may have seen this cable uh, in real life as well. So in coaxial cable, we have two concentric copper conductors. Oh, let me show you. This one is a copper conductor. This sheet, this sheet that you're seeing, this sheet that is present in front of you. This one is a copper conductor, and this wire, it's a copper conductor as well. So this is the main wire which carries the signal. So we have two copper conductors. One one is present right here, and the other one is there. So we have two concentric. They're not parallel. They're concentric. So it is bidirectional, and it is used in broadband as well. It has multiple frequency channels on cable, and it has 100 MB per second per channel capacity. And then we have fiber optic cable. They have glass fiber carrying light pulses, and each light pulse is donates a bit. It has a high speed operation. Fiber optic cables are very fast. They allow tens to hundreds of GB per seconds of data transmission rate, and we have low error rate in the fiber optic cable. So repeaters spaced far apart, immune to electronic noise. So these optical fibers are immune to electromagnetic interferences. Okay, so then we have, let's talk about the unguided physical media, which includes wireless radio, signals carried in various bands in electromagnetic spectrum. So we have no physical wire in case of unguided physical media. So broadcast, half duplex, sender to receiver, propagation, environment effects. So the environment in which the unguided physical media or the wireless signals propagate, the environment, it affects, it has effects on on the signals. So the reflection, obstruction by objects, interference, noise. So these are all the effects that an environment impose on the signals. So we have different radio link types, which includes wireless LAN, which is also known as Wi-Fi. It provides you with the tens to hundreds of MB per second speed, and the range for the Wi-Fi is tens of meters. And then we have wide area. We have already talked about this wireless LAN and wide area networks. Wide area means the 4G, 5G, LTE, 3G technology. So these are provided by your cellular or the mobile phone operators. So we have the tens of MB per second data. The capacity is tens of MB per second over 10 kilometers. So it's the wireless LAN is for shorter distances, and wide area networks cover a larger distances up to 10 kilometers. Then we have Bluetooth. It's a cable replacement whenever we want to share files and media wirelessly without cable. We use the Bluetooth. It covers very short distances, and it has very limited transmission rates. And then we have terrestrial microwave, it's point to point and 45 MB per second channels. And then we have satellite signals up to 100 MB per second. Starlink provides the capacity of up to 100 MB per second downlink, and then 270 millisecond and end-to-end delay, geostationary. So this is it until now. We have discussed about we have discussed the network core in detail. We have seen what our packets we have seen what our hosts, we have seen what our access networks. We have discussed different types of residential access networks, which included the DSL and then the cable based access networks. And then we studied about the physical media. We have seen the twisted pair cables, coaxial cables, and we studied about the guided and unguided media. So we have seen about the transmission delay, the packet transmission delay as well. and also the enterprise networks, wireless networks. So this is it about today. We will proceed with the chapter one. We will proceed with the remaining topics of chapter one in the upcoming videos. Okay, so in the upcoming video, we'll proceed with the network core. We'll study about the packet circuit switching and then the internet structure. So this is it for today. Thank you so very much. If you have any suggestions, if you have any questions, do let me know in the comments section down below. Thank you so very much.